Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback and the concurrence from each one of you, the quality of video as well as audio, is it perfect or not? If it is perfect, just write the perfect over the chat box and then we'll move ahead. And I would request to you guys at least share this session to your colleagues, your batchmates as well as junior, such that they will get connected with me. Because probably the festival time is going on, most of us might be busy in the Diwali preparation and all, but still if you guys can share this session, it would be great for us. It would be great for us. So just I wanted to have the feedback. Yes sir, perfect. Okay. Now the agenda behind the today's video or the today's session is gonna be the differential equation. Keep in mind, as far as this topic is concerned, the 2 marks is fixed from this topic. Either you're from any of the branch, electrical, electronics, instrumentation, mechanical, civil, chemical, from any of the branch, the 2 marks is fixed from this. So you can put it the heading, which is gonna be the differential equation. Which is gonna be the differential equation. Is the part clear? Differential equation. Now, at very first instance, I would just like to understand why the differential equation is so important. Many of us exactly do not know why the differential equation itself is required and why we study differential equation. If I ask one problem from any of the student from the engineering background, what we do in differential equation, then he is going to say, we will be calculating the general solution of the differential equation. Sometime from the function we are going to extract the differential equation, and he is not aware beyond this. That's the worst part of your knowledge. Keep in mind, you should have a clear-cut understanding why this differential equation itself is so important. That is why the questions are keep coming from the differential equation. Differential equation. See, one equation you have seen many of the times in class 9th, 10th, 11th as well as 12th in case of mechanics, where we have one equation of motion, V is equals to of U plus of AT, U plus of AT. May I know what was the V over there? The V was velocity at time or at any arbitrary time t. V was the velocity at any arbitrary time t. Similarly, what was U? U was velocity at time t is equals to 0. Sometimes you also refer this as initial velocity. A is the acceleration, and t is the time. Okay. We have used this formula many of the times. But may I know from where this formula have come? This formula is nothing but a general solution of a differential equation. If you want, I can recall that. It's nothing but the rate of change in velocity with respect to the time is equals to the acceleration. Now, for the time being, what I am assuming, the acceleration is independent from time, or you can say the acceleration is constant. If the acceleration is constant, definitely you can get its general solution. See, if you take its general solution, if you can use the concept of variable separable. The dt comes over here, you will take an integration. Once you will take an integration, arbitrary constant c has to come in the picture. Once you take the integration of dv, it would become v, here it would become at, and here it would remain c. Where the v is supposed to be function of t. What I will do now, just to calculate the precise value of c, or just to calculate the particular solution of this arbitrary solution. This is nothing but the arbitrary solution. We'll be talking about the arbitrary solution in the great detail probably in tomorrow's class. And one more thing, tomorrow we won't have any class, so you guys can happily enjoy Diwali. And even in advance, I would congratulate to all of us, wish you happy Diwali in advance. Probably we won't have class tomorrow, but from day after tomorrow again we'll come back with the same enthusiasm. So how much effort, how much entertainment you want to bring within your life, you bring it tomorrow itself. Because from day after tomorrow again we'll come back with a rigorous study plan. Is that part clear? So here V is equals to of 80 plus of C. V is equals to of 80 plus of C. Now what I'll do, I'll keep t is equals to 0. What does it mean of it? In that case, we wants to have the velocity at time t is equals to 0. So now we are interested in particular solution. So I have seen, or I have observed, the velocity at time t is equals to 0 is found to be u. So what I am going to do over here, I am going to feed t is equals to 0, and in that case the v of t would become u. So the equation would become u is equals to of a into t, where the t is simply equals to 0 plus of c. So the c would be simply equals to of u. So may I know what's gonna be the particular solution of the dB divided by dt is equals to a? It's the very same, which is nothing but v is equals to of u plus at. I want to ask one thing. Which is more powerful? dV divided by of dt is equals to a, which is a differential equation, and it's the solution of the differential equation, or you can say simply it's a function. Which function it is? It's stating that the v is a function of t, where the u and a is probably going to be constant. May I know which is more powerful, the differential equation or this function? Which is more powerful? I want the input from the comment box. Just comment over the comment box which is more powerful, this differential form of equation or just function itself. Tell me. I'm just watching over the comment box. Tell me which is gonna be more powerful. So the first input have come in a form of differential equation. Only 7 number of concurrent viewers I can see over the comment box. I would request at least share this session, because many of us must be busy in the Pauli preparation and all, but at least you can bear at least 1 hour with me. Differential equation. Why so? Try to understand. Differential equation. See. So far I have taken the rate of change in velocity was a constant factor, and hence the a was dealt as a constant factor, and when I was supposed to calculate its general solution and the particular solution, the a was taken constant, and that is why it became 80. That's a different thing together. Almost in all cases, like if we gently drop a piece of stone, this case prevails. Why? Because once you drop a piece of stone in from rest, what will happen? The a is simply gonna be plus of g. If you throw a piece of stone upwards, the a is gonna be minus of g. And keep in mind, at least in the vicinity of earth, the value of a is constant. But what will happen? Like in practical scenario, if you are driving a bike, what will happen? Within certain moment of time, you start accelerating your bike, and after certain moment of time, you start de-accelerating your acceleration. What does that mean of it? That means the a could also be the function of t, and once the a becomes a function of t, keep in mind, this formula is not going to be survived. What does that mean of it? That means a could be the function of t, like a could be t square, could be t cube, depending on the different fashion you are driving your bike. May I know in that situation whether the same particular solution will survive? No, it's not going to be surviving. Like I have taken an example. Let's take a person, Rahul, is driving a bike and he's keep increasing his accelerator. So what will happen? Let's take it becomes the a becomes a constant times of t. What does the b into t indicates? If b is positive, as the time increasing, the acceleration is keep increasing. And once you will talk about the general solution is simply going to be b is equals to of bt square plus of c. Again, if you will keep t is equals to 0, you will be getting the particular solution as bt square plus of u. Not only that, even you can have the pattern of acceleration like c times of t square, c times of t cube, so on and so forth, they will result the different values. They will result the different values. See, that means this differential equation can almost handle all sort of the variations in the acceleration, whereas this formula is just blindly used in case the acceleration is constant. Acceleration is constant. So you guys could have come across many of the times this difficulty, why the differential equation is being used. So you can just write one line: the differential equation can use the wider range of the practical scenario. Write down. The differential equation can address the wider range of the practical scenario. Unlike its solution or function. Even if you want, you can give the example. It has got a limitation. This formula is valid only if a is constant, whereas this differential equation is valid for any arbitrary value of a. Whether the a is constant, whether a is the function of t, whether the a is decreasing with respect to the t, whether the a is increasing with respect to the t with the different speeds. Till this point, each and everything is clear? If it is clear, just write clear. Then we shall move ahead. I want the reply from each and everyone. Is that part clear? I want the reply from each and everyone. Clear, sir? Clear. That's great. Now what we are going to understand, how we get the general solution from the differential equation. See, a little bit background, a little bit basic idea you guys must have, then only you are going to appreciate the concept of the differential equation in the great sense. So you can see the graphical solution of the differential equation. Graphical solution of the differential equation. Now try to understand, we have got a differential equation. dy by of dx is equals to of maybe x. So I would like to get the general solution of this differential equation using a graphical solution. May I know why the graphical solution has been introduced deliberately? You guys could have seen, whenever the graph comes in front of you, that complete understanding becomes very easy, and you try to grasp the concept in the much simpler way. That is why, rather straight away jumping into the general solution of the dy by dx is equals to x, I am taking the help of the graphical solution, and then we'll move it to the general solution of the dy by dx is equals to x. Is that part clear? So let me do one thing. Let me take a plane. It's my xy plane, and hence this is x-axis, this is y-axis. Is that part clear? Now what's happening hereafter? May I know what the dy by dx indicates as x? dy by dx is nothing but the rate of change in y with respect to the x is solely depends on x. May I know how the x is getting changed? How the x is getting changed? Here x is 0. Here, just a minute, here x is 1, here x is 1, here x is 2, x is 3, x is minus 1, x is minus 2, x is minus 3. Let me write it down. Here x is equals to 0, 1 here it is, 2 here it is, 3 here it is, minus 1, minus 2 and minus 3. Now may I know, if you keep x is equals to of 0, what does it mean of it? Rate of change in y with respect to the x is 0. That means the function is gonna be a dy by dx is what? The dy by dx is nothing but the tangent over the function at x is equals to 0. If you are keeping x is equals to 0, at x is equals to 0 is nothing but 0. So you will be having tangent which is very parallel to the x-axis. Either you take at y is equals to 1, maybe y is equals to 2, maybe y is equals to 3, so on and so forth. See, like this. Like this. Is that part clear? Now, similarly, if you go at x is equals to 1, now the dy by dx becomes 1. What does that mean of it? That means the tangent having slope is equals to a 45 degree. Why? The tangent is nothing but the tan of theta is equals to slope of that curve, and if the slope of that curve at x is equals to of 1, would be equals to of 1, that means the tangent is going to be 45 degree. So the tangent would be sort of 45 degree here, 45 degree, sort of this. Yes. And similarly, once you keep x is equals to of minus 1, tan of theta is equals to minus 1, it will bring it to the minus 45 degree. Minus 45 degree. So here it would become minus 45 degree. See, minus 45 degree. Minus 45 degree. Is that part clear? Once you'll go at x is equals to 2, that means the dy by dx would become 2, and as the value of slope is increasing, the value of theta would increase. That part you should be knowing. If, if you have taken tan of theta is equals to m, if m is increasing from 0 to infinity, theta would increase from 0 to pi by 2. That happens in trigonometric. So what will happen at 2? At 2 what will happen? Even it slope would become even steeper, sort of this. Is that part clear? And here again. So end of the day, if the unidirectional lines are connected together, let me take the help of blue curve. The unidirectional lines are connected together, sort of this. Similarly, you can say this. Here, yes. The slope is increasing here, even it is more higher. Even it could be towards the lower side also. Yes. May I know which type of structure it is? It's the upper facing parabola. And graphically, if you would like to visualize what is the solution of the dy by dx is equals to of x, you will get to know the y is approximately equals to of x square plus c. Why I am writing c? Because this equation also satisfies this differential equation. This curve also satisfies this differential equation. Moreover, if the complete curve is shifted towards upside or downside, the value of c is continuously changing. So you can say here, if it crosses through the origin, the c is 0. If it crosses through the y-axis at the worth as 1, the c is 1, and similarly minus 1 and minus 2. Put together, you can very well see graphically we could visualize the dy by dx is equals to of x would have the solution as a parabola which is upper facing. And why the c have come? Because all of the different upper facing parabolas are going to satisfy the requirement of the differential equation dy by of dx is equals to of x. And you can see very well in first class itself I have told here the tangent is 0. Here almost tangent is 45, here it's a minus 45, here it would be tan inverse of 2, here it would become tan inverse of 3, here it would become tan inverse of minus 2, and here it would become tan inverse of minus 3. That's it. So till this point I feel it must be clear to all of us. All of us. Is that part clear? So if it is clear, just write clear over the comment box. Then I'll get to know that each and everything is just going into your mind. Just put it clear over there. And then we'll move it to the just basic part of the differential equation. Need the comment from each and everyone. Yes, sir, clear, sir. Okay. Now, let me go ahead with the core part of the differential equation, which is straight away there in your GATE syllabus. Write down the differential equation again. Write down the differential equation again. So may I know what is the differential equation? May I know what's the equation? The equation will have the left hand side as well as right hand side. So if the equation is said to be differential equation, that means at least one derivative term or one derivative coefficient must be present into your equation. So write it down. The differential equation is an equation which contains at least one derivative term. So write down. It's an equation contains at least one differential coefficient. Yes, and this is more than enough to say any equation as a differential equation, Here you can have few number of examples. You can have the examples. Like, you can have the first example. dy by of dx is equals to of 1 plus of x square divided by of 1 minus of y square. That's a different story together, that the right hand side is a function of x and y, but as far as this equation is concerned, you have been allocated or you have been present with our differential term, which is nothing but the dy by dx. So dy by dx is a responsible term to make this equation differential equation. That is what I am saying. Any of the equation which contains at least one derivative term would become a differential equation. If you want, so you can take the second example. Like, example could be dy divided by of dt square, maybe the 2 is getting multiplied over here, 3 dy by of dt plus of maybe x, not x, yt is equals to of 3, Again, may I know how many number of differential terms are present with it? So obviously we have got this as a differential term, this as a differential term, and here this as a differential term. If you want, we can rub it out. So again, it's a type of differential equation. Even sometimes the differential equation can also be written in a very different way. Sometimes we get confused, but you need not worry about it. You can have even, like, you can have even e to the power of x dx plus e to the power of y and dy is equals to 0. Although you might not be appreciating whether it's a form of a differential equation or not, what will be happening? You just divide e to the power of x dx, both are the side. Either you divide e to the power of y dy, both are the side, then you will get to know you will be having a derivative coefficient in terms of dy by dx, or maybe in terms of dx and dy. You will get to know about it. So what I am going to do, e to the power of x dx got divided in both other side. So the result is simply going to be 1 plus, here it would become e to the power of y divided by of e to the power of x. You can simply write this as a e to the power of y minus x, and here it would become dy by of dx. And again, as you have come across a derivative term present into your equation, by default it would become a differential equation. Everyone, I would just suggest to each and everyone, whatever I write over the digital board, it should straight away come to your copy. You need to maintain a proper copy. Is that part clear? Even we can have the fourth example. This equation has been seen in 11th and 12th once we were studying about the wave equation, and even in engineering also, the mechanical guy, when we talk about the oscillation, once the string is just oscillated from one side by keeping one side fixed. And similarly in electromagnetic field theory, when we talk about the propagation of wave in 3D space, where the electric field and the magnetic field changes with respect to the time as well as the space. There you can have this relationship. You can have this dou square of E divided by of dou x square plus of dou square of E divided by of dou y square plus of dou square of E divided by of dou z square minus of 1 upon V square or Vp square of dou square E divided by of dou t square. Dou t square is equals to 0. The electronics guy can appreciate this formula in the better way. But what's the difference between the differential equation we have seen so far and the differential equation which we have introduced just now? The one difference here, one difference. Here the y was always getting differentiated with respect to the x, or I can say I was always curious, or I was always focused to get the rate of change in y with respect to the x. Here the rate in change in y with respect to the t, here in rate of change in y with respect to the x, but here we are interested in finding the rate of change in E. We'll see what is E over there. E is nothing but the electric field intensity which has been pertaining along with the traveling wave. E, which is a function of x as well as y as well as z as well as t. Obviously it is supposed to happen. If an electromagnetic wave was radiated from this point, so after some distance the electric field E would be different. That means the E is supposed to be a function of how much x has been traveled, how much y has been traveled, how much z has been traveled. Not only that, even you will see the strength of the electric field intensity at that same fixed point, you will see it will also change with respect to the time. So what happens? You would again have a classification of the differential equation in the two different categories. What are those? The first category where the dependent function have the dependency over only one independent variable, and hence you have a derivative with respect to a single independent variable. But secondly, this is a uniform plane wave equation. Obviously. And now similarly, if you talk about this, what is happening over there, the E is not only the function of space. In space also you have got the three different numbers. The E can change with respect to the x, y and z, and now in terms of t also. So just write down the classification. Classification. So the differential equation I am just classifying in the two different part. Most of the time you are going to face the problem from the ODE, which we call it ordinary differential equation, and similarly the second kind is going to be PDE, which we call it partial differential equation. You need not to write so much thick definition of ODE and PD. We'll write short and sweet definition of the ODE and PD such that I would be able to address the problem in gate examination. Is that part clear? So now ODE is ordinary differential equation and PD is nothing but the partial differential equation. What does it mean by the ordinary differential equation? Where we used to have a dependent variable and the rate of change in dependent variable with respect to the only one variable. So write down, we have function depends on only one independent variable. But here in partial derivative, at least you'll have a function which depends more than one number of independent variable which have been x, y, z as well as t. So you can write the function, the function is going to be E over here, the function is going to be y over here, the function is going to be y over here. Function depends on depends on at least one independent variable. At least two independent variable. And next important factor, differential term will not have variety. Straight away you can write will not have variety. But here at least two variety you should have. Rather writing big definition, those things are not going to be in much use, at least in case of crash course. So you can just understand in this way. So as far as the ordinary differential equation is concerned, you will be having rate of change in a certain dependent function or rate of change in certain dependent variable with respect to the only one independent variable. Like you can see the y seems to be a dependent variable and the y is going to change as per the x alone. Here y is going to change as per the t alone. Here y is going to change as per the x alone, but here once you talk about this, the e is supposed to be the function of x, y, z and t. That's it. That's everything is okay. But yes, e is supposed to be changed with respect to the x, y, z as well as t. So this sort of differential equation would come under the partial differential equation. In real world, each and every dependent function at least depend on 2 or 3 number of independent variables. So you say in practical scenario, most of the time we deal with the partial differential equation, but as far as the gate is concerned, 95%, 95 to 97% the questions are supposed to come over the ordinary differential equation. So you guys need not to focus over the partial differential equation. Yes, within the partial differential equation I am going to talk little a bit about the important zone from where the questions have been keep coming. So that part only you have to focus on, and the remaining your focus would be over the ordinary differential equation. May I know how the partial differential equation have come? Why? Because the E is or the electric field intensity involved with the wave, or we can say traveling wave, is the function of x, y, z and t. So what it means, in future we are just interested in calculating the rate of change in E with respect to the x, keeping rest of the factor constant. This situation can occur, no? The E is depending on the 4 different independent variables. Now what I am saying, dou E by of dou x is nothing but, for the time being I have kept y, z and t constant. Yeah, please keep quiet. Now just I am focusing over the rate of change in electric field with respect to the x, that would become dou E divided by dou x. That means the rest of the component is kept constant. Kept constant. Is ODE also known as total derivative? No, I have not seen. In mechanical heat conduction, obviously, even I am going to take few of the problems from HMT, heat and mass transfer. You need not to worry about it. If I have come to teach mathematics, so I have taken almost all examples. That is why the first example which I have taken, that was the problem from the mechanics of the mechanical. Even I would take one problem from the circuit also, if the time permits. I know how many guys are attending my class and how to make you guys engaging. That part I know. That is why I am going to take the varieties of the examples, so that the electrical, electronics, or I can say the student who are from the circuit stream should also enjoy, and who are from non-circuit stream, they should also enjoy. Is that part clear? Now let me go ahead with the next slide. Focus over the ordinary differential equation. ODE. Focus over the ordinary differential equation. Write it down, the heading is ordinary differential equation. And in ordinary differential equation, once in a while the question have been coming. Tell me what about the order of the ordinary differential equation and what about the degree of the ordinary differential equation. Write down. So we are basically focus over the order and degree of the ordinary differential equation. So let me do one thing. Yeah. So basically I would be talking about the order of the ordinary differential equation, and secondly I would be talking about degree of the differential equation. If you guys are aware with the order of the differential equation and the degree of the differential equation, you can comment over the comment box. May I know what's the order of the differential equation? Order of the differential equation is nothing but the highest derivative present into your ordinary differential equation. Just write this only. Highest derivative present. Just by giving the example of few important questions, you guys would able to grasp the concept of each and everything. So it's the highest derivative present. Highest derivative present. Is that part clear? Degree is gonna be the degree of highest derivative. Highest derivative where or when, you can write when all derivative terms are free from radicals, logarithmic function, exponential function, or any trigonometric function. Any trigonometric function. Function of space and time. Power of highest derivative. Yes. Few of the comments have come over the comment box. So, as far as the ordinary differential equation is concerned, the first we are going to discuss about its order. The order is nothing but the highest derivative term present into your differential equation. We will see by taking few number of examples. And may I know what's the degree? The highest derivative term which is being present into your differential equation. No, just focus over that, and whatever the degree it possesses, that becomes the degree of the differential equation. But few of the important point everybody should write now. Few of the very important point everybody should write now. If the order is being referred as O and the degree is being referred by D, keep in mind the few important properties. I know these are the points where you guys are going to stuck, and probably 8 to 9 number of problem have come just by based on this particular concept. Is that part clear? Write down the few of the important properties. First, order or degree will always be a positive integer. Would always be a positive integer. If you want, you can write would always be a natural number. If you're what I am saying? So probably in between the video got stuck. Just I wanted to take the feedback from each one of you. The quality of video and audio, is it perfect or not? Just write perfect and then we'll move forward, because there was a technical issue for the time being. But so just I wanted to have the feedback from each one of you. The video and audio, is it perfect or not? If it is perfect, we'll move ahead, because there was a little bit technical issue in between. So I wanted to have the feedback from you guys. Tell me the quality of video and audio, is it perfect from your side or not? Yes sir, perfect now. Kapil Pandey, now you can check, guy. Kapil, now you can check. Perfect. Now perfect, no? Okay. Now I know that in few of the questions you guys are going to be stuck. The first important point, as I said, the order and degree will always be a natural number. Like you cannot say, sir, order of my differential equation is somewhere 3/2, 1/2, or the degree of my differential equation is somewhere maybe 5/2. That situation will never be occurred. And similarly, order will always be present. That means once you have a differential equation, always you would be able to calculate its order, but degree may or may not be present. Mostly it used to be present, but you may have a special case of problems where the degree is not present. Just by giving few number of examples, I will show you guys which are the problems would come under this segment where the degree of that differential equation is not defined. is not defined. So let me take few number of problems, and keep in mind those problems have been straight away picked up from your gate examinations, So you guys, you can easily say, so the questions, 4 or 5 number of questions which we are going to experience now, they have been straight away picked up from your gate examination. So the first question may be, let me write down the first question first, maybe, and thereafter second. I will take third question thereafter, and thereafter I will take the fourth question. Let me take the first question. And the first question is x dy by of dx is equals to of y. I wanted to get the order as well as the degree of this differential equation. I would just suggest one thing, always focus over the order at first step. Why? Because for getting the order of the differential equation, you need to focus over the derivative which have got the highest derivative, obviously, and the degree of the highest derivative itself is going to decide the degree of the given differential equation, So may I know what's going to be the order of this differential equation and what's going to be the degree of this differential equation? I want the input from each one of you. What's going to be the order as well as degree of this differential equation? I want the input from each one of you. So one input have come from Shreyash. The order is 1 and degree is 1. We'll try to understand. See, if you are able to visualize this problem, may I know how many derivative terms are present? Only one derivative term is present. May I know how many times the differentiation has been taken place? Only one time. No. If it could have been d square y divided by dx square, then I could have been told that the y is a function of x and y has derivated 2 times. So order how many times the differentiation is being taken place? Only one time, sir. Only one time. But if you talk about the power of the highest derivative term present into the differential equation, that becomes degree. May I know what is the power of dy by dx? That's a simply equals to 1. Still I know many of the students will get confused, sir. Can you take more number of problems? No issue, I am going to take more number of problems also. Now, next problem, and I know this problem could be a little bit a complex problem to deal with. See, the problem is d square y divided by of dx square plus of 2 times of dy by of dx to the power of 3 or raised to 3 times of y is equals to of 4. Now I want the comment from each one of you, what's going to be the order and what's going to be the degree for this particular problem. I want the order as well as degree. Tell me, what's going to be the order as well as degree for this particular problem? D square y divided by of dx square plus 2 times of dy by of dx to the power of 3 plus 3y is equals to 4. I would repeat one thing once again. Tomorrow we won't have class, but yes, from day after tomorrow we'll again have class on same time frame, that is in between 2 to 4. So the answer have started coming 2 and 3. The mistake I was expecting, one mistake have already been occurred by Srinu. Keep in mind, I first talk about the highest derivative term present into the differential system. May I know what's the highest derivative term? That's a d square y by of dx square. So may I know what is the order? The number of time the derivative has been taken place, or highest number of time derivative has been taken place. That's a 2. May I know what's the degree? Degree is nothing but the power of the highest derivative term. Sometimes the student get confused. In case of order, they talk about the highest derivative term, that's a 2, and in case of degree, they talk about the highest degree and they write 3. No, you need to focus over the highest derivative term itself, and the power of the highest derivative term is going to decide your degree, and the degree is simply going to be 1. Is that part clear? So probably this problem is clear to all of us. Now what I am going to do over here, let me take a next question, and keep in mind this question have already come. In examination. Let's see what's that. The problem is d square y by of dx square to the power of 3 divided by of 2 is equals to of dy divided by of dx. I need to get the order of this differential equation as well as degree of this differential equation. Order as well as degree of this differential equation. Order as well as degree of this differential equation. See, as I have said earlier, calculation of order is going to be utterly easy process. Just see how many maximum number of times the derivative have been taken place, that's a 2. So the order is clearly known to be 2. Order is clearly known to be 2. But once we calculate the degree, each and every derivatives must be free from any of the radical powers, exponent term, logarithmic term, as well as trigonometric functions. So what you will do now, you will put the effort to free this derivative term from the radical power. Then what you will do, you will just take square both of the time, taking square both of the side. So it would become d square y divided by of dx square. Obviously it says square, do not get confused in it. And here it would become dy divided by of dx, and as the square was taken towards the left hand side, the same has to be prevent over the right hand side. So may I know what's gonna be the degree over there? Again, you would be taking the power of the highest derivative, which is nothing but 3. So order is 2 as well as degree is 3. Order is 2 and as well as degree is 3. Is the part clear? Now let me take a next problem, and definitely this is a problem where most of the students are getting stuck now. Yes. If you have a function dy of dx square, let's take, it is being operated with a sinusoid or with a trigonometric function sine, and let's take is equals to of dy by of dx. Now I am interested in calculation of order as well as degree. Similarly, even for the sake of better understanding, I can design the next question, which is gonna be the question number 5. And now the little bit change I am introducing, and you can say here ln of dy by of dx is equals to of maybe x. You can write x. Tell me what would be the answer for this. I want the answer for the question number 4 as well as question number 5. Question number 5. Order is 2. You need not worry about it. The number of highest times the differentiation has been taken place, that's gonna be 2. May I know what about its degree? I want the degree from each and every one. Does not exist. Who have given this answer? Shreyas have given this answer. What about the Vikrant? What about the remaining of us? The degree does not define. Why? Because any of the derivative, if it is getting connected with the sinusoidal signal, it has the problem. See, try to understand. If the sine is forced to get transferred towards right hand side, what will happen? It would become sine inverse of dy by dx. Is still a derivative is trapped with a trigonometric function, and still if the dy by dx is trapped, or in general any derivative is trapped with a trigonometric function, the degree would not be defined. Sir, is calculus part is totally, we'll talk about that. Is that part clear? So D is not defined. Now many of the people may also ask, sir, why? I'm just giving a little bit brief about it. See, if you really want to learn the mathematics, I think engineering mathematics will take 120, 130, 140 hours. So anyways, as far as the brief introduction as well as concise form of the crash course is concerned, where my basic motive is to give the complete marks, or you make you guys capable such that you would be able to extract all of the marks in gate examination. I need not to go into that great detail, but yes, may I know what's the expansion of sine of x? That used to be x. Here the x is simply d square y divided by of dx square minus of x cube. Here it would become d square y divided by of dx square to the power of 3 divided by of 3 factorial. Then x to the power of 5, it would become d square y divided by of dx square to the power of 5 divided by 5 factorial. If you want to write this in a form of series expansion, now can you tell me what's going to be the highest degree of the derivative term? Every derivative term is the derivative of the second efficiency. Is that part clear? The first has the degree as 1, the second will have 3, third will have 5, and as it would come under the power series expansion, it would be keep increasing to 7, 9, 11 and 13. Nowhere it is going to be converging to a certain degree, and that is what I have said. Whenever a derivative term is applied or derivative term is being applied with a sinusoidal signal, maybe in general trigonometric signal, exponent, logarithmic, you will lead with a series expansion, and once you lead with the series expansion, definitely you cannot confine to degree. Yes. And if you bring this side, it will again become sine inverse, and it would go for a power series expansion. Again the same problem comes. Now here the problem is little bit different. Fifth, what I will do, the log has been shifted towards right hand side, so dy by of dx would become simply equals to of e to the power of x. May I know what's going to be the order as well as degree for the question number 5? May I know what's going to be the answer for the question number 5? Obviously it's simply going to be degree. Order is nothing but 1, and may I know degree? Now easily you can say the sir degree does possess, and the degree is going to be 1. Once we'll talk about the general solution of the differential equation, in that case we'll get to the number of arbitrary constant which will come in case of general solution, that would be exactly equals to of the order of the differential system or differential equation. You can write it down. During general solution, the number of arbitrary constant during general solution arbitrary constant would always be equals to the order of the differential equation. Even you can see this factor once we'll be dealing with the higher order linear differential equation with the constant coefficients. Is this part clear till this point? If it is clear, just write clear. We'll move ahead. Till this point is each and everything is clear? If yes, we'll move ahead. And one more thing, any type or any sort of feedback you guys wanted to give it to me, you can just put it over the chat box. So I will try to improve those parts from the next video onwards, provided it must be beneficial to you guys. So we can have a little bit chit chat in between. Any sort of doubts, any sort of technical as well as non-technical doubts you guys are having, you can just ask over the comment box. So next 5 minutes we can have a little bit chit chat sort of thing. So in chit chat, at least I can confine the domain. Any sort of suggestions you guys are giving to me, that you can put it over here, and any type of technical and non-technical doubts you guys are having, you can ask over here. So let me wait. One doubt, sir. Yeah, tell me, Kapil. Tell me what's your doubt, Kapil? What about the remaining people? Everything is clear. That means you guys are going to rock in gate examination. So probably let me remember the names. Sir, can you please do some MSQ? Yes, Amal Ajay, that part I have taken. Even I have started creating few number of MSQs. That is well taken, Amal. That I have already started implementing. That is not a problem at all. So at cusp point, function is not differentiable. Obviously, yes. Yes. Why at cusp point the function is not differentiable? If the cusp has been formed, let's take at x is equals to c. At c minus, you would be getting a different slope of your tangent, and similarly at c plus, you would be getting, let's take c minus, you would be getting a different slope of your tangent, and similarly at c plus, you would be getting a different slope of your tangent. And that is why in case of differentiability test, until and unless the LHD is not equals to of RHD, or I can say the derivative at c minus and similarly at c plus, if it is not same, that means the formation of function is not smooth at x is equals to c, and hence the derivatives not exist. No, not at all. How? If I'll zoom, okay, let me zoom it. See, let me zoom it. How it will become smooth here? Still it is a point, no? Still it is a point. And you cannot draw the tangent over a point. Why? How the tangent is being defined? Let me ask one thing. How the tangent is being defined? The tangent is a straight line, passes through that point. Only once. Yeah, like this. How many number of tangent you can draw? Infinite number of tangent you can draw, taking the reference of that point, and hence the unique tangent is not defined, and hence the differentiation at x is equals to c is not defined. Anything else? Sir, can you arrange daily 1 hour practice session after end of the course? That we'll see. Okay. Let me shrink it back. Yes, 100%. So probably things are clear to all of us. Now what I'll do, let me go ahead with the next. So we just talked about the degree as well as order. Yes. Now let me talk about the linear and non-linear differential equation, and the problems are keep coming from this domain. Write down the linear as well as non-linear form of the differential equation. The heading would be linear as well as non-linear form of the differential equation. Just focus over the linear differential equation, and if the structure does not meet the requirement of the linear differential equation, by default it would become non-linear differential equation. So first write it down, the pattern of the linear differential equation. Let me write it out. Let's take Pn d to the power of n y of dx to the power of n plus of Pn minus 1 d raised to the n minus 1 x raised to the n minus 1 plus is equals to of q. Keep in mind this structure of the differential equation would be said as a linear differential equation only P of n minus 1 till P naught either they are a real coefficient. Anyways, we call it coefficients. Keep in mind we call it coefficients. Coefficients. We call it coefficients. Either they must be a real number or they must be the function of independent variable alone. They must be the function of independent variable alone. Like here you can have e to the power of x, that will do, no issue. Here you can have ln of x, that's not an issue at all. Here you can have 2, that's not an issue at all. Here you can have 3, that's not an issue at all. But you cannot keep this like e to the power of y, maybe e to the power of y square. Why? Because all of the coefficients, they must be either a real coefficients or they should be the function of the independent variable alone. So may I know what is the independent variable? Y is getting differentiated with respect to the x, that means the y is dependent variable and x is the independent variable. Agreed? Agreed? And whether you want or don't, but yes, all of the derivative coefficients which we have had, no, they should always be in first degree. If you want, we can write. But yes, the q, again, either the q could be a real number including 0, yes, no, real number, that means anything, 1.23 e pi 0, anything, or could be at worst the function of x, could be at worst the function of x. You can write here g of x, you can write over here as a g of x, you can write over here as a g of x. Is that part clear? Is that part clear? If the format of the differential equation deviates from this structure, having this many number of inputs which you should keep in your mind, the problem will become non-linear form of the differential equation. Non-linear form of the differential equation. Note, you can write, note, if starting from Pn going till P0, if everything or every coefficients are numbers, that means none of the coefficient is a function of x or for the time being independent variable, then the linear differential equation is called linear differential equation with constant coefficient. Coefficient is called the linear differential equation with the constant coefficient, and this is very, very important as far as the gate is concerned. Is the part clear? So let me take few number of problems, and by seeing those number of problems, you guys have to reply whether those problems would fall under the linear form of the differential equation or the non-linear form of the differential equation. One more thing you can write. If you talk about the q, even the linear differential equation can be further bifurcated. If q is non-zero and q is 0, non-zero, that means if it is linear, it could be 1, 2, 3, 4, minus 1, minus 2, minus 3, or even function of x. If q is non-zero, it's called non-homogeneous form of the linear differential equation. Non-homogeneous form of the linear differential equation, and if the q becomes 0, it's called the homogeneous form of the differential equation. So I am seeing the number of live viewers are keep decreasing. Probably you guys are very busy in the poly preparation and all. At least focus over the gate DS. Is the part clear? The q is not equals to 0. And similarly q is equals to 0. Is the part clear? So let me go ahead with few number of questions. Tell me whether it's a linear or not. D square y divided by of dx square plus 2x square plus maybe y is equals to of x square. This is what my first question. First you had to say whether it's a linear or non-linear, and if it is found to be linear, you had to further categorize whether it's a form of homogeneous or whether it's a form of non-homogeneous. I want the comment from each one of you. That's the first question. Even we can write the second question. The second question, whether will it fall under the linear form of the differential equation or the non-linear form of the differential equation. Similarly, question number third, question number fourth, question number fifth. Question number fifth. Now, little bit change I am introducing over here. That could be the next question. That's the question number 3. Let me go ahead with the next question. Now you can have, just a minute. Or you can do one thing, you can smash this to 0, 0. I want the answer from each one of you. I want the answer from each one of you. Tell me, among the 5 or the 4 number of questions you are see over the board, among them which will fall under the linear form of the differential equation, and if it falls under the linear form of the differential equation, which classification would it come under? Tell me, tell me. I want the input from each one of you. I want the input from each one of you. First question, what's going to be the best most answer? Tell me what's going to be the best most answer. I want input one by one, no? For the first question, first write what's going to be the input, whether it's a linear or not. If it is linear, whether it's a form of homogeneous or non-homogeneous. Whether it's a form of homogeneous or non-homogeneous. I'm just waiting for the replies from you guys. Obviously, why linear? The constant is 1, which can do. The constant is a function of x, which can do. And here again the y is getting multiplied with 1, again it will do. And right hand side has to be a function of x or constant. Obviously, it's a linear form. It's a linear form. It's a linear form. It's a linear form. But as the right hand side is non-zero, it would be non-homogeneous. 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 The first question. What about the second one? Second one. Now the second one, again it's a linear. Here it's a constant. Sorry. What about this? Here it's a function of x. Keep in mind. Here it's a function of x, but the coefficients should not be any time the function of the dependent variable. Here the y is the term which is just making mistake in the complete differential equation. It becomes non-linear. It becomes non-linear. Is the part clear to all of us? Is the part clear to all of us? Non-linear. Non-linear. Is the part clear to all of us? May I know third? Yeah, you should write 1, 2 and 3. You guys are going to be an engineer and probably few of them could have become engineer. At least write 1, 2 and 3. Just writing homogeneous, non-homogeneous. How will I understand whether you are referring the first question, second or third or fourth? May I know third? Definitely this is the point where the most of the problems or the most of the students are going to be stuck. Now what they will understand, sir, because of this y square it would become a non-linear. No. Y is again a function of independent variable. How did we know that it's a function of independent variable? The derivative has been taken place with respect to the y. That means it is okay. I need not to worry about it. And even the right hand side, either it has to be a constant 0 or must be a function of y. Keep in mind, it's again a linear form of the differential equation. If we talk which classification it will come under, it would come under the non-homogeneous form of the linear differential equation. Linear differential equation. Third, non-linear. Who is the person? Kapil Pandey. Amal Ajay. I was knowing that. I was knowing that. Definitely I was knowing that. Now, Kapil and Amal, you guys had to again reply whether it's a linear or non-linear. Whether it's a linear or non-linear. So now I have given a clear-cut idea why it's a linear. I was knowing that you guys are going to do the mistake over the question number 3. Now again I want the reply from the Amal as well as Kapil. Beta, whether it's a correct answer or whether you guys have given a correct answer. Linear. What else? What else? Amal, you also had to correct yourself. It's gonna be a linear in nature. I know that just by seeing y square, you could have been jumped from your seat and you could have said, sir, no, sir, it's a non-linear. No, the things will not move in this way. Is the part clear? I know that. No, this sort of problem can be created. 50 to 60 number of problem can be created where definitely you guys are going to scratch your head. But no issue. It's a linear and it's a non-homogeneous. Non-homogeneous. Is that part clear? May I know the last one? May I know the last one? Whether it's a linear or non-linear? Obviously, it's gonna be non-linear. It's gonna be non-linear. It's gonna be non-linear. Till this point, each and everything is clear? Till this point, each and everything is clear? I want the comment from each one of you. 9 people are there in concurrent viewers. You had to write your branch in a short form and state and city. State and city. Because I am going to give few number of examples, so you guys would be able to relate in the better way. So each one of you who are concurrently viewing or watching my videos, you guys had to write your stream and thereafter the state as well as city you belongs from. I am going to give an example. Just I wanted to know you guys would be able to relate or not. Obviously, it's a non-linear. May I know what is the reason behind this? This square is the reason behind this. This square is the reason behind it. So whenever you are writing over the copy, you should also mark what is the reason which made this differential equation as a non-linear differential equation. Then only you will get to know about it. Then only you will get to know about it. Is that part clear? Mechanical engineering, Maharashtra, Kolhapur. Okay. What about the remaining people? EC Delhi. Okay, Kapil. EC Kerala, LFP. Okay, Amal. So I am going to give you one example from this circuit. I am going to give you one example from the circuit. See. I would give you one example from the circuit. Let's take, we have got a series RL circuit. Chemical Odisha. Okay, Vikrant. Okay, that's fine. See, if I am giving an example of a circuit, and similarly the chemical people and mechanical people can take an example of mass, damper and spring. Okay. Now what we are going to do, I assume the resistance worth across this resistor is R, and similarly the inductance worth across this inductor is L. This inductor is L. And what has been happened over here? External voltage V is being applied. And if I take a KVL. So may I know what would be that KVL? The KVL, let's take the current which flows through this loop is I of t, which would become R of I. Obviously, I is a function of t, plus of L di by of dt, which would become equals to of V, or you can say simply equals to of L di by dt plus of R of I is equals to V. Yes or no? Now may I know the equation which has arrived here, whether it's a form of a linear differential equation or whether it's a form of non-linear differential equation, whether it's a form of linear differential equation or whether it's a form of non-differential equation. And hopefully in next lecture I would also give an example of mechanical as well as chemical system. In chemical system you can have a tank, and from the tank you might be having an outlet, and the outlet will have a certain flow. The flow can be connected with the height of the tank as well as volume. You can have the differential equation for that also. I have been there in BARC, Bhabha Atomic Research Center. I have worked there for the 5 years, so I have a mixed feeling of each and everything. Although I am from electronics background, but the work which I was doing was the work for the instrumentation, where you had to control the several process conditions, which includes the flow as well as viscosity, velocity, temperature, density. So being an electronics engineer, now I am not an electronics engineer alone, because I had learned so many things regarding the mechanical. I talked about the flow of heat, I talked about the mass transfer, the many of the things I learned there. And anyways, that's the thing about it. Once you go into any prestigious organization, you will not be a chemical, mechanical or civil engineer. You will just become an engineer, because whenever you go into the great organization, you had to work with your team. Because if you're designing something, but if your design is not complying with the requirement of mechanical, civil, electrical, your design is going to fail. And similarly, if mechanical guy is going to design something and which is not in comply with electrical, civil and instrumentation, that design is going to fail. So end of the day, once you get into any of the prestigious organization, either you go through the MTech and get consumed in any of the good MNCs where the core hearted work is being done, you will become an engineer at last. Obviously. So may I know what would be the result? Result would always be a linear differential equation. And end of the day, I would like to say only one thing. If you have any RLC circuit, you will have mass, damper, spring, and similarly if you have a problem related to the chemical, all of the result would be a linear form of the differential equation. And that is why the RL and C, resistance, inductance and capacitance, are said to be resistance, inductance and capacitance are said to be. Sir, very happy to learn under you. Thank you, dear. Thanks a lot. So here RL and C, they are always said to be linear element. Many of the electrical and electronics student, if I ask this question, why the RL and C is said to be linear element, they have got the various number of inputs for this, but the exact answer they themselves do not know. RL and C, if it is present into the circuit level study, it will always produce a linear form of the differential equation, and hence RL and C is already been said to be a linear element. Is the part clear? So yeah, today at least I am seeing the number of concurrent viewers are very less. So I think it won't be good if I will be keep prolonging my session of this video. So I think it would be good that I can stop here itself. And before stopping my video, at least I would say, or I would wish to all of us, including your family, you, me and my family, happy Deepavali. Happy Deepavali in advance. So how much entertainment you want to have, you can have today as well as tomorrow, because wherever you are there, no, you just put your 100%. Whether you are roaming with some friend, just put your 100%. Whether you are sitting with your book, put your 100%. Until and unless you are not putting your 100%, no, you will be puzzled here and there, and the productivity is not going to come. Sir, when you are covering Fourier series, Shreyas, may I know from which branch you are? Probably, if time permits, the last topic is gonna be Fourier series. Why? Because the Fourier series has already been part of the signal system in electrical, electronics and instrumentation. That is why I am saying probably if time permits, the last topic would be the Fourier series. So anyways, end of the day, I would just say wish you happy Deepavali to all of us, to all of our family nearby and dearby. Okay, then we'll meet day after tomorrow, obviously at 2 p.m. Thank you very much, and wish you happy Deepavali once again.